Hello again. In this topic, we're going to introduce the concept of a critical number of a function. We've been using this, some of this already, but we haven't been using the same terminology. So let's start with the definition of what we mean by a critical number and then go into some examples of finding them. This is a really important topic in the study of curve sketching, and so we really need to get this down before we move ahead. So a definition of a critical number. We will say that x equals c is a critical number of f of x if f of c exists and either f prime of c equals 0 or f prime of c does not exist. So what is this saying? X equals c is a critical number of f of x if f of c exists. So that's saying that c is in the domain of the function. Right? That's what that part's saying. C is a number that's in the domain of the original function. F prime of c equals 0 or f prime of c does not exist. So that's telling us that the function is differentiable, right? F prime. We can calculate the derivative of the function, and either f prime of c equals 0. Now, that means those numbers are what we have been calling stationary points, right? F prime of c equals 0. We've been calling those stationary points. So if we think about what that means, those are points where the derivative is 0. So those are points where the tangent line is horizontal. Okay? Or f prime of c does not exist. If f prime of c does not exist, so that's saying that those are those special situations where the function may not be differentiable at that point, but c is still in the domain. So those are what we would have. Those are corners, cusps, or vertical tangents. But basically, what we're doing here, if we are asked to find a critical number, we think about the domain of the function. Right? We need to know what the domain is. Right? We think about the domain. We calculate the derivative. And then we find any places where the derivative equals 0 or the derivative is undefined. So we ask ourselves, where is derivative 0? Where is the derivative undefined? And that's basically what we will need to do to locate any critical numbers of a function. So let's see a quick example. We're asked to find the critical numbers of f of z is 2z to the 4th minus 16z cubed plus 20z squared minus 7. So this is a polynomial function. So its domain is all real numbers. All right, the domain is all real numbers. That's our symbol for all reals, in negative infinity to infinity. We can easily calculate its derivative. F prime at z, using power rules and just simple methods here, we'd have 8z cubed minus 48z squared plus 40z plus 0. So there's our derivative function. Now notice that this derivative function is also a polynomial, and so it's defined everywhere as well. So we're going to ask, where is the derivative equal to 0? So now we're going to say, well, can we solve? Where is 8z cubed minus 48z squared plus 40z equal to 0? And now we have to use techniques that we learned in algebra. We can do some factoring here. Everything's divisible by 8 and z, so we'd have 8z by z squared minus 6z plus 5 is 0. We can continue factoring. That's 8z by z minus 1 by z minus 5 is 0. So then setting each factor to 0, we would say then that z equals 0, 1, and 5 are critical numbers. Of f of z. Those are the critical numbers of the function itself. And we would have called these the places where there would be stationary points on the curve. These are the places where the derivative is 0. These are places where the horizontal tangent would have a slope of 0. But they're also very important in our understanding of curve sketching, which we'll get to in a later section. So now we're just going to go through more examples of these ideas of how to find critical numbers for some different types of functions.